convey the equation of a plane. Equation of a plane requires 3 points: A, B, and C. Okay, so A has some values coordinates 3, 2, 1. B has some coordinates, I call it 4, 0, 1. And I have C, I have some 5, 6, 7 of the coordinates. Right? So if I want to create a plane, I will need 2 lines, right? 2 lines will do. So symmetrically, I don't know whether I have this word, but you have this plane over here. That's the meaning of a plane, right? So minimally you require 3 points to create a plane. Okay, so how do I have 2 lines? Okay, how do I create these 2 lines? As you can see, vectors can help us do that. So I'm gonna have a vector AB with an arrow over here and AC. I'll require 2 vectors first. Alright, so when I calculate these 2 vectors, okay, I just recap to you, if I want to go from point A to B, I require an AB vector. Alright, so point A plus a AB vector will give you equals to B, right? And then I bring this A over to this side, minus A. So AB is equals to B minus A. And therefore, I take this coordinate 4, 0, 1 minus the coordinates of A, which is 3, 2, 1. I would have 1, minus 2, and 0. I would know that this AB vector is 1, minus 2, 0 with an arrow stating that is a vector. Right? So now similarly we have AC over here. So AC is equals to C minus A. If you don't know how, you just click back to 1 minute ago. You just check it out. So I do out the 5, 6, 7 minus the coordinates of A. Alright, so this is this and this is this. Simple as that. 5 minus 3 is 2, 6 minus 2 is 4, 7 minus 1 is 6, 2, 4, 6. I have this dude over here. And this vector is 2, 4, 6. Now that I've created something like it seems like a line, but it's a vector. So we somewhat have created a point. Someone created a plane. Damn. Anyway, so to create a plane already, the next step is to have. Okay, so I just write it down. So what we have done just now, okay, is to first create 2 vectors as what we have did for AB and AC. The next thing we're gonna do is to actually find a normal vector to these 2 vectors. So what the hell is normal vectors? A normal vector is a vector that is perpendicular. Okay, maybe I should draw it in with a thicker line. Okay, so a normal vector is a vector that is perpendicular to AB, the vector AB, and also perpendicular to vector AC. So I repeat again, this normal line that is coming out of this picture, if you like imagine. So it's like coming, like vroom, and then like zoom out to somewhere else, out of the picture. But anyway, so it's perpendicular to AB, vector AB, and vector AP. Vector AB and vector AC. So therefore, how do I find this vector then? This normal vector. Later on, I'll explain why do you need this actually. So in order to find this normal vector, I'll require, I don't know whether you recognize my handwriting, but yeah, this is require cross product. If you remember cross product, it states simply it's not a good font, so I just write in terms of I, J, K. This is some random coordinates, okay? And then I put in my vectors. In this case, I have a 1, minus 2, 0 from AB, vector AB, and 2, 4, 6 from vector AC. And therefore, I just put it in over here in this form: 1, minus 1, 2, 0, and 2, 4, 6. Is it? Am I right? Yeah, okay. So this row over here, it's vector AB. Ignore if it's a capital or small capital, I forget already, but anyway, the meaning is there. So each of the row is like a, I think you get what I mean already lah. Okay, I just rewrite in terms of the rows. Okay, and therefore to do cross product, I would recommend you to use the rules of Sores. If you know how to find determinant, then you can use your own method. So but in this case, I recommend rules of Sores because it's easier. And therefore, what you're gonna do, I'll just use a thinner line now. I'll have this thing. Later on, you'll get what I mean already. So the sum of this blue arrows minus away the sum of this pink color arrows. Okay, so what do I mean by this? I have I times minus 2 times 6. Okay, so I have minus 12i over here, plus j times 0 times 2. I would have 0 because everything times 0 is just 0. And then k times 1 times 4, it's 4k. Right? Now, the sum of them, it's just this blue stuffs. Okay? And then I minus away the sum of the pink colors. So the pink colors is k times minus 2 times 2. I would have minus 4k. And then I times 0 times 4, because times 0, you know that it's just 0. And then plus j times 1 times 6, I have 6j, equals to 0, because determinant equals to 0, it's what it has to be done. So you have to do that. And from here you can hear that I really don't know why do I set it is equals to 0. And from what I have researched on, determinant d equals to 0 means that we have a non-trivial solution. A trivial mean trivial mean that is very let's search internet. Trivial means of little value or importance. That means it's like you can heck care on, okay? But if it's a non-heck care system, this means that it's very important. So what this means is that determinant equals to 0 means that you're talking about solution that is pretty much unique. Alright? Unique of a solution is just that you only have one solution, one special solution, that's it. So this is the meaning of determinant is equals to 0. Right? But it's totally not related to what we are talking about. Anyway, so you have to set it as equals to 0. That's very important. Now, let's rearrange this dude. Alright, so be careful of the minus sign. You're gonna multiply it in. So to rewrite this dude over here, I have plus 4k minus 4k, right? So minus 6j. Alright, and then now I gotta sum them up together. What I have, minus 12i plus, because there's 0i over here and this is j, so I have only minus 12i, and then 0j minus 6j, okay, 0j minus 6j, and then 4k plus 4k. Okay, so because somewhat you ignore this because I rewrite already okay, because I think you might confuse. Anyway, so k is equals to 0. Ta-da! So this dude over here, the coefficients are its normal vector. If I were to rewrite it, okay, I would have minus 12, minus 6, and 8. This dude over here is your normal vector, a vector that is perpendicular to your AB and your AC. Okay, so now we haven't finished yet. Okay, now this is the last step. Okay, introduce the method of dot product. Okay, last step, because what is my pen? Introduce the method of a dot product. So what the hell is dot product? Okay, there's two definitions: the magnitude of A and magnitude of, okay, maybe I should say magnitude of AB multiplied by the magnitude of AC cosine theta. If you don't know what is magnitude, it's just simply taking its, like, let's say 5, 6, 7, right? Anyway, let me see. Yeah, okay, I just say lah, okay, since fine. So I think, yeah, I don't know why this thing always stuck here. You see, cannot move already. This is supposed to give you the guiding of my mouse. Anyway, so 5 square plus 6 square plus 7 square, everything square root, is equals to your AB. I mean AC vector lah, okay, in this case AC, which is this thing over here, right? If you remember my plane lah, okay, my plane is coming from A to C lah, okay. So this magnitude is just simply using somewhat of a Pythagoras theorem type of method. Okay, so the magnitude of AB and magnitude of times magnitude of AC, I will have multiplied with cosine theta is equals to 0. Then this means that they are 90 degrees. What the fuck am I doing? Yeah, true, yes. Because when you sub in 90 degrees into cosine theta, you will have 0. Everything times 0 equals to 0. And therefore, this means that the magnitude of AB, this is AB, and the magnitude of AC, it's perpendicular to your normal vector. That's its meaning. 90 degrees, 90 degrees. Alright? This is the first definition. The next definition is A dot B is equals to 0. That's just when you're talking about when you're the two vectors multiplying to each other. So if I have AB, so let's redraw again since okay, so I have AB and I have AC, and I have a normal vector over here. So in order to prove that AB is perpendicular to AC, okay, actually this one shouldn't be AC, this one should be a normal vector and should be its magnitude. Okay, anyway, the concept is that they are 90 degrees and but you will not be using that for this channel, but still my fault. So I would think that this is a normal vector, so a normal vector multiplied by another magnitude of a vector, so it's not this lah, okay, normal vector. So this maybe I should rewrite this yellow color line is the normal vector. So the normal vector multiply with, let's say, AB, this is AB, has to be equals to 0. This is the second definition. Alright, so this is exactly the same as this one, just that it's in terms of cosine theta, that's all. Okay, sorry for this confusion, I don't know what the hell am I doing just now, but simply said, that's the whole general idea of that. So let me rearrange it all. Okay, so this is the first method, this is the second method. Okay, they both means the same, both vectors are 90 degrees apart, so this is the meaning of that. So you can also write AC in this case, just now is AB ma, so AB is this dude over here. Okay, so now AC is this one, right? So AC is also perpendicular to your cosine, to your normal vector, is equals to 0, and so on and so forth for this one. So like AC, that's right lah, equals to 0. But generally, you can write here, I mean you can write in terms of this, or you can write in terms of this. But please take note that this is not the equation of the plane yet, but it's almost there. So I'll introduce you to the equation of the plane in the next video because I'm running out of time. So I shall see you there. Bye bye.